Okay, y'all, I've walked around, every group has an answer, okay? How many streamers can you make, Mark?
6.
6. Is there a remainder?
Yes.
What is the remainder?
If you're talking yards, the remainder is 1/4 yard. If you're talking streamers, it's 1/3 of a streamer.
So 1/4 of a yard, which is actually 1/3 of a streamer. So, Mark, what did y'all use for your one hole?
Here's the little 4-part.
They used the purple for the one hole because it's already scored into fourths. Okay? So, Toby, what did y'all use for the one hole?
We use the round
They used the brown one because it's scored in
8.
8, so that could be used. Who used a different hole? I think Faith Group did. What did y'all use for your whole yard?
I used the red,
How many reds?
1, 2, 3, 4 reds, and then I added the green for the 3/4.
Okay, so she used the red for the whole, four reds as one whole yard. And then she had to add a green for
The 3/4.
the 3/4. Okay, Tim, what did y'all use?
We used the red also, but we only used 2 reds.
Okay, so they used 4 reds and y'all used 2 reds. Why did y'all use just 2 reds?
We used 2 reds and 3 whites for the 3/4.
Okay,
Because then we broke everything into whites.
okay, so they broke yours down to the smallest unit?
And we only had 1, so.
Okay. So do you see how many of the groups used a different one hole? So earlier when we were talking about changing the holes here, remember? When you let your kids pick the hole that they want, they have to realize that the denominator has to work with that. And it's a little higher level thinking than me just telling them, use the purple because it's already scored in fourths, right? Or use 2 reds because 2 reds would be 4. Or use the brown because that's 8, okay? So that worked out a little better. So the pattern blocks is an area model for fractions. The Cuisenaire rods is a linear model, meaning what? It's a length. You're talking about just the length. And kids need to see both of those. They need to see the area model, they need to see the linear model. Primarily because in algebra, they're going to have lots of linear things, okay? They're going to have graphs and all kinds of things that work with lines, okay? So in the elementary school, K-5, lots of area models for fractions, you know, circles, rectangles, all kinds of things. They also need to bring in the linear model with the Cuisenaire rod. So I don't know what your position is, but if you're in a position that you can go in and guide them into what to use, that would be very helpful, okay? All right, so you remember we talked about last summer the mathematical habits of mind, and when Patty was here, she talked about the science habits of mind, which I unfortunately don't have. But there are ways of thinking that help the kids understand how to problem solve. They're not born with those habits of mind. Those develop through multiple experiences with the concrete. Remember my story about when I was growing up. My mother started teaching when I was 4. I was 4, my brother was 2. There wasn't kindergarten back then. So I had 2 years at home with a lady who helped us named Mamie. I loved Mamie. My brother didn't, he was afraid of her, but he hid under the bed, but that was okay. He grew to love her. She did snuff. Remember me telling Mommy she did snuff? And the snuff cans came in an oval can like this. And the empty cans she would give to me, and I would go out and play in the mud, you know, with the cans. And I realized at a very young age, 4, that if I could squeeze that in and make it a circle, I could get more dirt in that can. So what was I learning about then that I didn't even know I was learning? Spatial relations, volume, surface area even, all kinds of things that I learned quite by accident, just by being given the opportunity to have that odd-shaped can to play with. It did not make my mother very happy. My mother was, she just pretended that Mamie did not dip snuff, but we all knew she did. She would send a 4-year-old and a 2-year-old carrying a red wagon with Coke bottles to be returned. 3 blocks down the street to Highway 69 where the country store was that we shot. John, have y'all ever been down Highway 69? Extremely busy highway now, but at that time it was just a little country road. And we were not worried that somebody would kidnap us as made our way to the store. Anyway, so here are the geometric habits of mind. Reasoning with relationships, investigating invariance. What's an invariant? What's a variable? Something that can change. So what is an invariant? Something that does not change. Okay? Generalizing and balancing exploration with reflection. Those are the 4 geometric habits of mind. Which ones of those did we exhibit in the activities that we just did? Did we do any reasoning with relationships? Tell me how. Tell me what you did. Yes, ma'am?
When we were going from the hexagons down to the trapezoids and then breaking them down into different shapes to make them fit together.
Okay, so you were reasoning with the area of the different shapes in the pattern blocks. What about investigating invariance? Did things either not change in that problem or what? Does not change. Variant changes, so invariant does not change. What did not change in our problem?
The area of the shape didn't change. The shapes we used to create that area changed, but the area itself was constant.
Okay, so we investigated the constancy of the area of the shape, and then we reasoned with other areas. What about generalizing? Did you generalize anything? Generalizing is the big focus in Algebra 1. Kids have to be able to generalize, take the few things that they did and generalize. Margaret said less or more. Will the answer be more than 1 or less than 1? Will it be more than the first number or less than the first number? How do you know? And did we explore? Yes. And did we reflect? Which is what we're doing right now.
Yes.
So yes. Okay. You would want a written reflection from your kids. Okay. More than just this verbal that I'm doing with you. Okay. So here are the algebraic habits of mind. Doing and undoing. Did we do any doing and undoing, such as addition undoes subtraction, subtraction undoes addition? Did we do any doing and undoing there? You're shaking your head yes, Rochelle. What did we do?
Multiplication with and division.
Okay, we did do multiplication and division, and they do and undo each other, right? Okay. What about building rules to represent functions? I don't think we've done that yet, have we? That was going to be in the next part of the lesson, which we probably won't have time to get to. Okay? So when we pick up next time we meet, I'll start with that part, which is really kind of cool. I really like it. And abstracting from computation, did we do that? The abstracting from computation kind of goes along with the generalizing. So did you solve a problem or 2 or 3 or 4 and then say, oh, I see, this is going to work every time? Okay, abstracting from computation. Did we use any of the properties of math? Yes, what properties did we talk about? Multiplicative identity, right? And what else? Commutative. Did those just come down from heaven like manna? Yes. No. Over the centuries, people realized, mathematicians realized that it doesn't matter if you add 3 plus 2 or 2 plus 3, you're going to get the same answer. They abstracted that property from lots of computation. I mean, centuries of computation. Centuries. So who gave us 0, by the way? 0 the hero? Who gave us 0? Hercules. Hercules.
The Aztecs.
I don't know if the Aztecs or Mayans had it. We don't use theirs.
Was it the Arabic?
We use the Hindu Arabic numerals. So the Hindu Arabics gave us the 0. Did the Romans have a 0?
No.
No. They just had those long strings of numbers. To add those, can you imagine? Have you ever had a math course where you had to add Roman numerals? I have. It's tedious.
I did.
It's not fun.
Oh, Lord.
What about the Babylonians who were prior to the Romans? No zero. What about the Greeks in between Babylonians and Romans? Did they have zero? No. So these mathematical ideas that we take for granted took centuries to develop. And thank goodness they did give us the zero, because that gives us our place value system. So if we want to write for our national debt, if we want to write our national debt in Roman numerals, there's not enough space on the page to do that. But because we have place value, we can write it now in 2 sheets of paper instead of 100, okay? So that, I'm sorry, that was just my soapbox. So we're not going to get to do that. We're going to do that next time, because I want to show you a clip of a student who, well, I'm not going to tell you much about her, okay? After we watch this clip, then we'll talk about her. And I may show you 2, because there are 2 that are just so powerful to me. I'll make this come up. You techie people. Then I get to techie people. Has to be somebody young. Yeah.
Somebody sticking a sandal under his whatever you have around so it's a good place to do. I don't know what it was.
While we're trying to get this to I want you to notice this table right here has been making mosaics all day long. And Margaret said it helped her think. She could listen and move these things around. A lot of boys, the tactile kinesthetic learner, which is primarily boys, some girls too, such as Margaret, they learn better if they can move things while you're talking. So they learn better. When my youngest was 3, I took home, go to the video clips, and then go to Gretchen. I took home big tubs of my pattern blocks for him to play with in the summertime while I was cooking dinner. And he would make these huge mosaics like this and cover almost the whole floor of the family rooms. Hours he would spend making those. So he learned about congruency, because these 2 lengths are congruent. He learned about area. He didn't know he was learning it, but he did learn about the area. He learned about similar, because he would make similar shapes with different sizes. So he learned a whole lot, and he is the most spatial child of my 3 children. He is the most spatial. He can climb anything. He repairs those wind turbines that you see. So if you have children at home, take your pattern blocks home and just let them play with them. And then later you can talk about congruency and similarity and all of that. Yes, ma'am.
The research links playing with any kind of like Lincoln logs or any of those kind of things with developing spatial skills, and that's why we see fewer females with good spatialization ability rather than males.
Because they have dolls.
Because they have dolls, Barbies.
Yeah, yeah. And my 2 granddaughters, I can attest to that, because they play with dolls all the time. And my grandson plays with stuff. Okay, let's pay attention up here. If I could have your attention. We're going to watch Gretchen first, and then we're going to watch Rachel, if we have time. So Gretchen is in the 2nd grade, okay? I don't think she's going to be able to make this screen bigger.
I can practice it, but it might mess up the videos.
So let's not do that. I know in my methods class I can't make them any bigger, so if you can't see, you're going to need to move to where you can see, okay? So go ahead and start, Gretchen. And I'm going to, is that okay?
Yeah.
All right. Gretchen is in the 2nd grade, okay? We'll discuss her after we watch the video. I hope you can hear her. I hope the speakers work.